Hey guys, today we're going to be looking at the second part of Target 5A. Target 5A is still all about coordinate geometry. So the two biggest things we're going to be looking at today is midpoint and distance. Okay? So the midpoint of a segment is a point that divides a segment into two congruent segments. So it's exactly what it sounds like. It's the middle of a line. The distance formula is a great formula to know, but we're not really actually going to use it that much. We're going to use something that we already know. The distance we basically already know how to do. Okay? So let's look at example 1. Example 1 says find the midpoint of each segment. So, here we go. Our midpoint formula is basically it's finding the average of your x's and finding the average of your y's. The middle of your x values, the middle of your y values. So that's where our formula comes from. X2 just means your second x plus x1, your first x, divided by 2. Okay. We do this because right, it's just like averaging. I'm adding two things together and then dividing by that number. Same thing with my y. Y2 plus y1 divided by 2. The biggest reason we do the second x first and the first x second, I think they're almost flipped, is because while for midpoint it doesn't matter as much, when we get to later formulas, they'll be in the same order and it does matter. So just get really used to the fact you do second first, first second. Okay? So midpoint is this. So then my second x is 4. My first x is -2. So 4 plus -2 all over 2. My second y is -7. My first y is 3 all over 2. So 4 plus -2 is 2 over 2. -7 plus 3 is -4, 2. Right? And then I'm going to divide. 2 divided by 2 is 1. -4 divided by 2 is -2. My midpoint of those 2 points is 1, -2. All right, looking at B, I'm going to move this over just a little bit. Looking at B, right? So for this one, it just gives us a graph, not a point, but it works the same way by just finding what those points are. Okay? So this is -3, 1, right? And this point is 6. So we're using the same formula. So we're going to start with our second x. And we'll always read like left to right. So our second x is 6. And our first x is -3. Over 2. And our second y is 6. And our first y is 1. And then divided by 2. So that's 6 plus -3, that's 3 over 2. And then 6 plus 1, that's 7 over 2. And then from there, we really can't do anything else. If we could divide like we did in this example, right, we would. But here, these don't reduce in any way, so we just keep it as 3 over 2 and 7 over 2. So that is our midpoint. Okay, so that's midpoint. Pretty simple. You're just finding the average of your x and average of your y's. Now we're going to look at something that we call partitioning a line segment. So a midpoint will split my line segment directly into two congruent pieces. Okay, so it's exactly halfway. But let's say I want to go a third of the way, a fourth of the way, any other fraction. Then what we're doing is actually partitioning a line segment. We're not finding the midpoint. So when I'm partitioning a line segment, we have our 2 points still, x1, y1, and x2, y2. Okay? This should say convert the ratio into a fraction, not the fraction into a fraction. Like so, right? So convert your ratio into a fraction. So if the ratio is a to b, your fraction would be a over a plus b. And we'll do some examples with that. Then I subtract those two numbers and multiply it by the ratio, and then add it to the first number. Okay? So subtract your x's, multiply by the ratio, add to your first x. Subtract your y's, multiply by the ratio, add to your first y. So let's look at example 2. Right? Oh, finally, your last step is to write them as an ordered pair, right? This is still a point somewhere on your line. Okay? So example 2, find the coordinates of P that partitions the line segment 3 to 1 with endpoints 6, -5, and C with -2, -1. Okay? Order matters for you. My order definitely matters. So this, whatever point I'm given first is 1. Whatever point I'm given second, right, is 2. So that was step 1. Step 2, convert my ratio into a fraction. So I have this 3 to 1. So my fraction is going to be 3 over 3 plus 1, which is 3/4. Okay? So there's 2 different ways these questions will be asked. Sometimes they'll say, like, partition it into 3 to 1, or they'll say that it goes 3/4. Right? If it tells you a fraction already, it's done number 2 for you. Right? So if it gives you a fraction, you just don't have to worry about number 2, which is nice. Then my third step I'll start with my x's. Next, I'm going to subtract x2, -2, minus x1, which is 6. -2 minus 6 is -8. I'm going to multiply that by 3/4. So that's my fraction. And I get -6. And then I'm going to add x1 to that. So plus 6. Which equals 0. So that's for my x's. Now I have to do my y's. So I'm going to subtract y2 minus y1. So -1 minus -5. -1 minus -5 is +4. Multiply by my fraction, which is 3/4. Equals 3. And then I'm going to add y1 to that. Right? So plus -5. And that equals -2. Alright, then our last step, right, is to write it as an ordered pair. So I'm just going to say 0, -2, and that's my answer. Don't forget to write it as an ordered pair. So with practice, this process will get easier. Okay, it's kind of a lot. It seems like kind of a lot of steps. It's not that many, but the more you practice it, the easier it will be. Let's look at the next page. We're going to do one more example with partitioning a line segment. So again, our first step is to label our points. X1, Y1, and X2, X2Y. Okay. So then I have to create my fraction. Step 2, right, from 1, 2. So my first number is 1, and that's over 1 plus 2. I then add them. So my fraction is 1/3. Then my third step, starting with my x's, x2 minus x1. Always start with the second one. So 2 minus -7 equals 9. I'm going to multiply that by 1/3. 9 times 1/3 is simply 3. And I'm going to add that to x1. x1 is -7. So is -7. 3 plus -7 is -4. Now with my y's, always second minus first. 4 minus -2, again plus, equals 6. 6 times 1/3. 6 times 1/3 is simply 2. And then I'm going to add that to y1. So plus -2 is equal to 0. 0 will always be a 0. Okay. And then my final step is just to write it as a point. So my point is -4, 0. And that's all it is for partitioning a segment. It's really not that much work, not too bad. Just remembering to get it into a fraction, and then a few little steps there. All right, the last example for distance that we're going to look at is finding the distance between -2, 1 and 1, 5. While you can try and memorize that whole distance formula if you would like, and it's going to work the same no matter what. I think the easiest way is, if you're not already given a graph, go ahead and graph it, okay? Just like we did here, graph 4. Then, use exactly what we've been doing so far, which is Pythagorean theorem. Just use the distance formula or just use Pythagorean theorem. It's going to work out exactly the same, okay? The distance between these 2 points is the hypotenuse of the 2 triangles. So, all along the top, right, I have 1, 2, 3. Here I have 1, 2, 3, 4. Then I just have 3 squared plus 4 squared equals c squared. 9 plus 16 equals c squared. 25 equals c squared. C equals 5. And you're done. Okay? So distance is exactly what we've been doing, finding perimeter and all of that. So it's not anything new. And that's it for today. I will see you guys tomorrow. Have a wonderful evening.